Today we're solving quadratics, but we're going to do a different method than the last time. So the last lesson we solved the quadratics by factoring. And so today we're going to do something called the square root method. Now, the square root method only works if there is no x in the problem. So there can be an x squared and there can be a constant, but there can't be an x. So this one has an x squared and it has a constant, but it has no x. So as long as there's no x in the problem, then we can do this method called the square root method. Okay, so one thing I do want to say about the square root method, you always end up with two answers, and normally you'll see it with a plus minus in front. So first of all, what this answer means is that a positive 6 is an answer, and it means that a negative 6 is an answer. So that's what that means. Positive 6 is an answer and negative 6 is an answer. And so plus minus is just a faster way of writing that. Okay, so I want to show you why there are two answers. So I'm not working through the problem yet, but I want to show you why two answers work. So if I go back to this step right here where it says x squared equals 36, let me just write that over here. I want to show you that this answer works and so does this one. So I'm going to take my positive 6 and plug it into x. And I want to know if 6 squared makes 36. Does 6 times 6 make 36? Yes, it does. So that's why a positive 6 works. Now let's check the negative 6. So if I put negative 6 into the x and square it, does that also make 36? Does negative 6 times negative 6 make a positive 36? Yes, it does. Okay, so that's why we have two answers. So anytime, and you're not seeing it here, but anytime you want to get rid of a squared, you square root both sides, and the minute you square root something, you're going to slap down this plus minus. Okay, so one thing about the square root method is your goal is to get the x squared all by itself. And once the x squared is all by itself, that's when you square root. Okay, so both of these problems, their goal was to get x squared by itself, and then once x squared was by itself, then that's when both sides got square rooted. Okay, so let's just look at these. Okay, I'm going to start with the easier ones. And then the ones that are a little bit harder, I'm going to remind you how to do something that you've done before, but it's been a while. So I want to start with number 2. Now, you may not think that this looks easy because of the fraction, but it's actually really easy. Okay, my goal is to get x squared by itself. And once again, the reason I can do this square root method is because there's no x in the problem. I've got an x squared, I've got a constant, but no x. Okay, so to get x squared by itself, I'm going to move the subtraction of 1/4 by adding 1/4 to both sides. So to get rid of subtraction, we add. So negative 1/4 plus 1/4 zeroes out. Your x squared comes down. And then 0 plus 1/4 makes 1/4. Okay, once you're to this step, once your x squared is by itself, this is when you square root both sides and you slap down your plus minus. Okay, now on the left side, what you don't know is the squared and the square root, they cancel each other out. So all you're left with is x. Now what this means is it means the square root is over the 1 and the square root is over the 4. That's what this means. When you see the square root over the whole fraction, the square root's over the numerator and the square root's over the denominator. Well, these both happen to be perfect squares. The square root of 1 is 1, put your division bar, and the square root of 4 is 2. And so that's our answer. X equals plus minus 1/2. So what that means is a positive 1/2 is an answer and a negative 1/2 is an answer. And remember, I want two answers because the highest exponent is a 2. Okay, let's look at example 3. All right, so once again, there's no x. You see an x squared, you see a constant, but no x. Okay, so our goal is to get the x squared by itself. So how do you think we're going to get rid of the 5? We're going to divide by it. Okay, so let's divide both sides by 5. So then 5 divided by 5 is 1, so all you're left with is x squared. And 80 divided by 5 makes 16. Okay, so once x squared is by itself, this is when you square root both sides. Slap down your plus minus the moment you do it. On the left side, the squared and square root cancel, leaving x. And then 16 is a perfect square, so it's going to come out pretty. What's the square root of 16? 4. And that's our answer. Now, one thing I haven't mentioned that you may be wondering about is I'm not making these problems say equals 0. So if you're doing the square root method, they don't have to say equals 0. They can say equals 0 like this one did, or not say equals 0 like this one. So with the square root method, they don't have to say equals 0. With the factoring method, they do have to say equals 0. Okay, let's go to number 4. All right, so once again, there's no x. There's an x squared, there's a constant, but no x. So we're going to do our square root method. So my goal is simply to get x squared by itself. So what do you think I'll do first? Add 4. To get rid of subtraction of 4, I'm going to do the opposite and add. So when I do that, x squared comes down, and then 0 plus 4 is 4. Once x squared is by itself, this is when you square root both sides, slap down that plus minus. On the left side, the squared and square root cancel, leaving x. And on the right side, what's the square root of 4? 2. And that's my answer. So one answer is a positive 2, and the other answer is a negative 2. Okay, let's look at number 5. So there's no x, so I'm going to do this square root method. What do you think you're going to do to get x squared by itself? Divide by 9. Okay, so if I do that, the x squared comes down. And then if I could divide these, I would divide them, but I can't divide them and I can't reduce them, so we're going to leave it 25 over 9. And then once x squared is by itself, this is when you square root both sides. So I'm going to square root both sides. I'm going to slap down my plus minus. On the left side, the squared and square root cancel, leaving x. And then remember, this is like number 2. This means that the square root is over the 25 and the square root is over the 9. And these are both perfect squares. So what's the square root of 25? 5. Put your division bar. And what's the square root of 9? 3. So our answer is x equals plus minus 5/3. Okay, now let's do the 2 I skipped. Now I skipped these 2 because we're going to do something that you haven't done in a long time, and you probably won't remember it. So I'm going to remind you about it, and I don't expect us to be perfect at it yet, but eventually we will be. Maybe not perfect, but really good at it. Okay, so our goal is to get x squared by itself. How are you going to get rid of that 3? You're going to divide by it. That's how you undo multiplication. So then your x squared is going to drop. Now this time I can actually divide the 24 by 3. So I'm going to do that. So 24 divided by 3 is 8. Okay, once again, once your x squared is by itself, you square root both sides. You slap down that plus minus. And then on the left side, the squared and square root cancel, leaving x. And then the thing is, you can't take the square root of 8. 8 is not a perfect square, so you can't take the square root of it. Over here, I could take the square root of 4, which gave me 2. Over here, I could take the square root of 16, which gave me 4. So if this is a perfect square, you can take the square root of it and get something pretty. If it's not a perfect square, we're going to try to break it down. So this is the part you may not remember. So I know we've talked about our perfect squares before when we were factoring a difference of squares. So we've got 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, etc. You want to try to find the greatest number in this perfect square list that can divide into 8 evenly, and never look bigger than this number. So I only have to check the 1 and the 4. Well, 1 goes into everything, so I just kind of ignore him because 1 goes into everything. It's still a perfect square, but because it goes into everything, it's kind of useless for this. Okay, so can 4 go into 8? Yes, it can. Okay, so we write down that 4 can go into 8 how many times? 4 times what makes 8? 2. Okay, and then we simplify this. What's the square root of 4? 2. And then you can't take the square root of 2 because 2 is not in the list. So you just recopy square root of 2. Don't forget your plus minus, and that's your answer. So this is called putting something in simplest radical form. And you should have done it in Algebra 1. It's just a matter of remembering. And we are going to have a big lesson on doing this. So this is just kind of a precursor to that lesson. So I just want to practice a little bit now, but we'll become really good at it later. Okay, let's try that again. Looking at example 6. Okay, so there's no x. So that's why I'm allowed to do the square root method. And it doesn't have to say equals 0, remember. Your goal is to just get x squared by itself. So how do you get rid of the 2? You divide. So we're going to divide both sides by 2. The x squared drops. And then you can actually divide 96 by 2. So we want to do that. And you know what that is? 48. Okay, so once x squared is by itself, you square root both sides. You slap down your plus minus. On the left side, the squared and square root cancel, leaving x. And then is 48 a perfect square? Nope. So that means you can't take the square root of it and get anything pretty. So we're going to try to break it down. So let's think about our perfect squares again. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. Remember, I don't need to look bigger than this number. So looking at these numbers from here to here, except the 1, what is the largest number in this list that can divide into 48 evenly? Now, you may think it's 4, so let's look. If I take 48 and divide by 4, that's true. 4 goes in there. But let's look at the answer. Can my answer 12 be divided by one of these numbers? Yep, 12 can be divided by 4, so that means there's somebody bigger than 4 that can go in here. Let's say you thought it was 9. Well, it's not if you get a decimal. Let's try 16. And then look at your answer. If 3 can't be divided by any of these numbers, then that means you found the biggest one. And 3 can't be divided by any of these numbers other than the 1. So this is it. So 16 goes in there 3 times. Okay, so I'm going to rewrite it as the square root of 16 times the square root of 3, because 16 goes in there 3 times. And then let's clean it up. What's the square root of 16? 4. And then you can't take the square root of 3 because 3 is not in the list. So it just stays square root of 3. And then you recopy the plus minus. And that's that answer. X equals plus minus 4 square root of 3. So that means that a positive 4 square root of 3 is an answer. And a negative 4 square root of 3 is an answer. Okay, so the bottom part here mixes up this lesson and the lesson where we solve by factoring. Okay, so the directions say, solve the following by factoring or by taking square roots. So let's talk for a second. The only way I can use the square root method is if there's no x. So if there's no x, I can go ahead and do the square root method. But if there is an x, I'm going to have to factor. Now remember, if you factor, they need to say equals 0 before you begin. If you use the square root method, they don't have to say equals 0. Okay, so let's look at number 7. Does number 7 have an x in it? It does. So that means I have to factor this one. Okay, so going through our rules of factoring. First thing we always look for is a GCF. Oh, so since I'm factoring, I'm sorry, we need to make sure it says equals 0. And it does. Okay, so we can begin. Do we have a GCF here? We do. These both have an x. Okay, remember to build your parentheses after you take the GCF out. So x times what is x squared? X times x. X times what is negative 4x? A negative 4. Now I'm going to cover my GCF up and see if I can factor this. It's got 2 terms, but it's not a difference of squares because x is not a perfect square unless it has an even exponent. Okay, so I'm done with the factoring. So now I'm going to bring down my equals 0, and I'm going to solve. So remember, when something times something equals 0, it's either because this first number, x is 0, or it's because this second number, x minus 4, is 0. And then I just solve these two equations. Now this equation's already solved for because x is by itself. So to solve this equation, I would get rid of subtraction of 4 by adding 4. And what would that give you for an answer? A positive 4. So my answer is 0 and 4. Okay, let's look at the next one. Do you think I need a factor, or can I use the square root method? I can use the square root method because there's no x. There's an x squared, there's a constant, but there's no x. Okay, so with these, they don't have to say equals 0. This one does say equals 0, but it doesn't have to. So your goal is to get x squared by itself. So what do you think you're going to do first? Add 80. You tend to get rid of addition subtraction first. So we're going to add 80 to both sides. So then the 4x squared is going to come down. The equals is going to come down. And then what's 0 plus 80? 80. Okay, now remember, you're still trying to get x squared by itself. So how do you get rid of the 4? We're going to divide by 4. Okay, so I divide both sides by 4. And then 80 divided by 4 is 20. And then now that x squared is finally by itself, this is when we square root both sides. So I'm going to square root both sides. I'm going to slap down my plus minus. The squared and square root cancel, leaving x. And then can you take the square root of 20 and get something pretty? Nope. So I want to break it down. I want to find the largest perfect square that can go into it and how many times. So look up here at your perfect squares. Don't look bigger than the 20. Okay, so of these numbers here, what's the biggest one that can divide into 20 evenly? 4. And 4 goes in there how many times? 5 times, because 4 times 5 is 20. And then just clean it up. What's the square root of 4? 2. And then you can't take the square root of 5, so you recopy it and drop the plus minus. So our answer is x equals plus minus 2 square root of 5. Okay, and let's look at number 9. So looking at number 9, do you think I need a factor or can I do the square root method? I need a factor because there's an x. Okay, so remember it needs to say equals 0 before you factor. So I don't want my x squared to be negative, so I'm going to leave him alone. I want to move the x to the left and I want to move the 3 to the left. So if I do that, I'll have nothing on the right side. But what would my left side say? 2x squared minus x minus 3. Very good. Because to move a positive x, you would subtract it. To move a positive 3, you would subtract it. And then from here, I would factor it. I'm not actually going to factor this one, but I'm just going to start us off. Does this have a GCF? Nope. And then it's got 1, 2, 3 terms. So I would be a times c rooftopping it, and it would be drop, replace, drop. So I'm not going to work this whole problem, but let's just start it. Let's set it up. So what would you get if you took a times c? 2 times negative 3, you get negative 6. And you'd want them to add to make the negative 1 in the middle. Okay, let's just see if we can find the numbers. Does anybody remember what multiplies to make negative 6 and adds to make negative 1? A negative 3 and a positive 2. And from here, you would drop, replace, drop, etc. Okay, and that's all for this lesson. Smile.